Hey guys, how you doing? This is Mr. Douglas, 6th grade math. Well, I had some other fun ideas and videos I was going to do, and I'm just running out of time. You know what? Hats off to all you guys who've made a lot of videos and of you playing games or other kinds of channels. I learned a lot this weekend, and it's a very time-consuming process editing these videos, and I'm not even any good yet. So if I ever got good, it'd be even more time-consuming probably. So we'll get more videos loaded as we get ready for the end of year STAR test. Right now, I just want to mention some things you need to look up on your own. You can find short 1 to 2 minute videos online. There's tons of them to help you study, okay? So I'm going to give you a few topics and I'll give you a few strategies to help you. Don't forget to subscribe and hit the notifications bell so I can keep you updated as I add things. So the first thing I want you to know, we had finished off the data analysis except for one section left. There's quartiles, and really what you want to look up is IQR or interquartile range. So the bottom line is, you know how to divide something in half, and let's say this is 10, 12, 14, and this is 6, 4, 2. If this is a data set, the middle one is my median. You already learned that in the previous video. So now we're just going to cut the halves in half, okay? So if I go on this side and I do that, and I'm going to have a 4 here, we call that Q1, and we have this one, 10 and 14, that's the half of that side, so that's Q3. Technically, the median is Q2, but we just call it the median, okay? So that's how you set that up. And then the interquartile range from one of our last videos is the biggest number minus the smallest number, 14 minus 2. Interquartile range is the biggest Q, or quartile, minus the smallest quartile. So IQR is going to be 12 minus 4, okay? So in this case, it's going to be 8. But the range of the whole data set, 14 minus 2, is 12, okay? So that's a short lesson on interquartile range. You can look that up online. Some other things we need to know how to do. If you're dividing decimals, if they say you have 0.025 of something, okay, and you need to put it into little vases or vials of 0.0125, okay? How many vials do you need? Well, you have to divide those, okay? So this is as big as my vial is. I can't fit more than 0.0125 milliliters or whatever we're talking about here, okay? So I have to divide the 0.025 by the 0.0125. And I always tell people, I don't know where I got it, but whenever I say a decimal outside the division house is what I always call this. That's like a baby. Hey, who let the baby outside the house? We need to move back, copycat. However many places we move to get the baby inside, we need move the other baby over to make room. So 1, 2, 3, 4. 1, 2, 3. Oh, do I stop because there's no more numbers? Nope, you have to do the exact same thing. Okay, and then move a decimal to the top. Move back, copycat, decimal to the top. Now the cool thing is 125 goes into 250 2 times. So you can work that out. But I just wanted to show you that little technique for decimals. Other things you're going to need to know how to do. Turning a percent to a fraction. Okay, so if I said 20% and turn it to a fraction, well, percent, cent like century, means 100 years. Centipede is an estimation of a little thing that has 100 legs. Cent has a meaning of 100. So 20% means 20 per 100. So now it's a fraction, okay? But we don't leave fractions like that. We simplify. Anytime you have fractions, try to simplify them. So the first thing I call zero trick. We can divide the top and bottom by 10. It cancels out the zeros. I'm left with 2 over 10. Can I simplify it by anything else? Yes, 2 goes into 2 and 2 goes into 10. So if I divide the top and bottom by 2, I will have 1 over 2.